Yeah, welcome back, guys. So today I'm going to explain about Coulomb's force. So it is also called as inverse square law, Coulomb force, inverse square law. So it is explaining about force between two charges. The charges, either positive or negative. Both are positive, both are negative, can be. So in that case, Coulomb force is attractive or repulsive, whereas law of gravitational force is only attractive. And law of gravitational force, it is a universal law, but this is not universal law, Coulomb force, because it is not constant everywhere, depends on the medium. Permeability of the medium, you can see here, permeability of free space, epsilon naught, it depends on this value. And it follows the superposition of principle or principle of superposition. That means, so if the force between any two charges is independent of the intermediate charges. That means here Q1, Q2 are the two charges. There are infinite charges are there between them. The force on Q1 will be sum of the forces acting by remaining charges. The force on Q1 or force on Q and force on Q2 will be the sum of all the forces acting by remaining charges. But the force between Q1 and Q2 is always same. And force between Q1 and Q is also same. Because of Q2 placing this side, the force between Q1 and Q2 is not vary. And the force on Q by Q2 is not vary because of Q1. But the force on Q by Q1 and Q2 will be different. The force between any two charges is not affected by keeping the intermediate charges in between them. This is principle of superposition. The force on the charge can be added by all the charges placed in between or some distance from the charge. But force between any two charges is not changed by keeping another charges anywhere. So now, this force between the charges is directly proportional to Q1, Q2 and is inversely proportional to 1 by r square. And it can be written as the magnitude of force is equal to 1 by 4 pi epsilon naught into Q1, Q2 by r square. And vector form of the force is like this. So here 1 by 4 pi epsilon naught is called force constant value, that is equal to 9 into 10 to the power of 9 Newton meter square by Coulomb. So if force value is equal to 9 into 10 to the power of 9 newtons, that means if I consider the charges are 1 coulomb and 1 coulomb separated by the 1 meter distance, then I will get force is 9 into 10 to the power of 9 newton. This is the unit force between the two unit charges separated by unit distance. Means if charges are increased or decreased, the distance between them is increased or decreased, that will be multiple of this value. The force is multiple of this value for Q1, Q2 by R square. So now epsilon naught is the permittivity of free space. That means permittivity means the allowing, means capability or capacity of allowing the electric field line through that medium. Means electric field of by a charge. How much distance it can travel, how many field lines it can travel. So that is in electric field, it will come again. So that value is epsilon naught. We consider the epsilon naught. Epsilon naught is for free space. That means air or vacuum. So epsilon is permittivity of any medium. The K is called dielectric constant. And here K is dielectric constant and here K is, these two are different. So this dielectric constant is the ratio of permittivity with respect to free space. So means how many field lines or how much field is more or less compared to air medium. Means one charge in air medium, it is having some field. So the same charge is placing in another medium, how much field, how many field lines are traveling through that medium. That will be give the ratio K value. The K is equal to infinity for metal, means compared to air, more field lines will travel. And K is equal to 1 for air because it's the ratio of air and air. So K is equal to 0 for insulator, no field lines will be there. That is the comparison. So now here, epsilon naught value and its units I have given, K value and units I have given. So this is about simple concept related to Coulomb force, what is explained. So now the direction of the force acting on charges will consider now. So see direction of force. So here I have considered charges Q1, Q2, Q3. From the origin, they are in the position R1, they are in the position R2 and R3. R1, R2, R3 are the positions of charge Q1, Q2, Q3 respectively. So they are in XY plane. Therefore, Q1 is equal to X1, R1 equal to XY cap plus Y1, X1 I cap plus Y1 J cap. R2 is equal to X2 I cap plus Y2 J cap. R3 is equal to X3 I cap plus Y3 J cap. X comma Y values will be there for this Q1, Q2, Q3 points. These are the positions. Now the force between Q1 and Q3. Because these all are, I have taken positive, same are similar charges and equal also. Means similar charges, same sign. So force is repulsive. Similar charge means repulsive, that is away from the charge. And this direction of the force is along the line joining these two charges. This is F31. So here I have given see F3. This is the line joining 1 and 3. So between 2 and 3 in this direction. So between 1 and 2 in this direction. Repulsive force means away from the charge. Attractive force means towards the charge. So for that I have given here clarity, see how the forces are acting if they are attraction and repulsion having opposite charges. Means here plus Q and minus Q I have taken. In some of the cases I have taken. So now if the force on 1/3 is attractive, force on 1/2 is repulsive. So the direction is given like this. And on 2 also, force on 2/1 is repulsive, is away from the Q2 2 position, and by third particle means minus Q, that is means in this direction towards the charges. So here it is an equilateral triangle, angle is 60, and here 180 minus 60, that is equal to 120. So calculation of angle, you know, very clear. Two tails are two heads should coincide. That is the angle represent. There the angle art is there. That much you have to take. Coming into here on 3. So these two are positive charges. This is the negative charge. Therefore, only attractive force is acting on 3. So both are attractive toward this direction. Q is one charge is attracting third charge, and second charge is attracting also third charge, because forces directions are given like this. So now angle between those two is 60. So here you can calculate the force. Force are same. Plus Q minus Q. Force is same. Magnitude of force is same here. But resultant will be different. So here 60 degrees means √3 F will come. 120 degrees means F only will come. So on 2 the force is resultant force is only F. On 3 resultant force is √3 F. And on 1 also F only will come, because 120 angle cos 120 is minus 1/2, 2 get cancelled. Forces are equal, then F, that is vector addition we have studied, right? So now see, to calculate the force values when they are given vector form. So R1 and R2, R3, they have given in vector form. Vectors is they are given. So I want R13. So you know the addition of vectors. R3 is equal to R2 plus R3. Here I have given addition of vector. So R23 is equal to, I want R23 value. This is the distance between Q2 and Q3. Therefore, R23 is equal to R3 minus R2. So magnitude I want to find out means R23, magnitude of R23 is equal to subtracting R3 and R2 and root over x square plus y square. Now you will get answer magnitude of R23. So that we can substitute in Magnitude formula directly Q1, Q2 by R square. Otherwise, vector notation like this Q1, Q3 because it is Q2, Q3. Na? So means 1 and 3 means R1, 3 is the distance. Similarly, will follow 2 and 3 means here we will write 2 and 3 like this. So this is calculation of direction of the force. Direction of the force in different means in what direction force is acting and how much it is Q1, Q2 by R square. 9 into 10 to the power of 9 Q1, Q2 by R square. How much magnitude you know already. But in what direction you have to consider? The direction depends on they are positive or negative charges. Both are positive, both are negative means it is repulsive. One is positive and negative means it is attractive. So now some examples we'll see on application of Coulombs law. So now if we see these questions, first two questions I will explain combinedly properties of charge and Coulombs law, because in previous class I explained about the conservation of and means properties of charges, how energy is charge is conserved, and this one what we call this transferable charge is transferable, how it will take place and what are the problems I explain. So now here see, according to question first, the question I am converting into diagram, then physics will become easy. So two identical conductive spheres of small radius here, but for my calculation purpose I have taken big here, small radius are charged and placed at the 25 centimeter distance. Therefore, and at that time the force between them is equal to 1.728 newtons is given. Therefore, force is equal to formula we know. So substituting here Q1, Q2 values I don't know. I let it be Q1 on one charge and Q2 is another charge. One is because here see why I have taken positive and negative means here see in the question given attract each other. So in the question they have given attract each other. Attracting means one is positive, another one is negative. So which one is positive, which one is negative, that is your wish you can take, not a problem. Attractive each other. So now from this formula you will get Q1 and Q2. Similarly, so now what happened next statement you see. Next what is giving? Next they have given the sphere are now connected by a thin conducting wire. Connecting wire. Conducting wire means it will be transfer the charge and removed. The distance is not changed between them. They are removed now. So now the charge on these two spheres will be rearranged, right? According to transferable, charge transferable. So what I have to find out now? Here how much charge is there I have to find out. On these two spheres, what is the charge? That is Q1 dash and Q2 dash. So these are identical, we know very clear. So these are identical means the charge on Q dash and Q1 dash and Q2 dash is also similar. Right. So that means 2Q dash. This is final charge on these two identical spheres. Identical spheres means these two charges are equal. Therefore, 2Q dash or 2Q1 dash or 2Q dash we can take. So that will be initial charge is how much? Q1 minus Q2. The final charge is equal to initial charge. So this is over. Final charge is equal to, this is the final charge. Either 2Q1 dash or 2Q dash. So these two are equal. And Q1 minus Q2. Therefore now Q1 dash is equal to Q1 minus Q2 by 2. Therefore here I can write Q1 minus Q2 is equal to 2Q1 dash. So then Q1 is equal to 2Q1 dash plus Q2. Or Q2 is equal to Q1 minus 2Q dash. So that is Q1 values and Q2 values. But he is asking the amount of charge. Now when these two charges are recombined, now the force is equal to given 0.576. 0.576. So now we have to calculate the force formula again by using force is equal to K into the charge on these two charges Q1 minus Q1 dash and Q2 dash. Q1 dash and Q2 dash, these are charges. So now substitute, you will get one formula. So Q1 minus Q2 dash by 2 is equal to this much. So now to get the relation between Q1 and Q2, I am doing the equation 1 divided by 2. This is the second equation here. I have taken this as second equation, this is the first equation. 1 divided by 2 you do, you will get Q1 by Q2 is 1. Here Q1 minus Q2 whole square by 2 square. 2 square means 4. 4 will go up. 4 Q1 Q2 by Q1 minus Q2 whole square is equal to. So this answer, one equation, 1.72 into this one similar. So 0.576 into this one similar. So the similar thing will be cancelled and 0.576 is denominator and 1.72 is numerator. Therefore, like this will come. So now these two cancel means here 3 answer will come. Therefore, 4 Q1 Q2 is equal to 3 into Q1 minus Q2 whole square. Keep like that, 3 into Q. I have expanded like this. Otherwise, no need. 3 into Q1 Q2 whole square. Otherwise, Q1 minus Q2 whole square is equal to Q1 minus Q2 is whole square equal to what I can write? 4 Q1 Q2 by 3 I can write. So now you will get a x value is how much? Q1 plus Q2 is equal root over 7 root over 7 Q1 Q2 by 3 will get. So here root over 4 Q1 Q2 by 3 will get Q1 minus Q2. So after this, we have to find out the Q1 plus Q2 value by using the formula. Always remember this, when individual you have to find out in wherever. So Q1 minus Q2 whole square is equal to Q1 plus Q2 whole square plus, sorry, minus here 4 Q1 Q2. Or Q1 plus Q2 whole square is equal to Q1 minus Q2 whole square plus 4 Q1 Q2. So from this value, 4 Q1 Q2 value I know here already. And Q1 minus Q2 whole square value also I know from this here calculation. So now you will get Q1 plus Q2 value. Q1 plus Q2. Therefore, Q1 plus Q2 is equal to some x value consider. And Q1 minus Q2 is equal to some y value. Therefore, subtracting 2 Q1 equal to x plus y and Q1 equal to x minus y. Finally, you have to get Q1 and Q2 are equal. You will get Q1 is equal to Q2, that equal to minus 24 coulombs you have to get. So try this answer by this method. I hope you understand this. Right. So not Q 24. This is wrong answer. 24 not. So Q1 is equal to, you will get Q1 is equal to 6 into 10 to the power of minus 6 and Q2 is equal to minus 2 into 10 to the power of minus 6. So in quadratic equation it will come, this is. So from the quadratic equation you will try means you will get Q1, Q2 values 6 into 10 to the power of minus 19 coulombs and Q2 value minus 2 into 10 to the power of minus 6 coulombs. So this is the process of calculating. So now next model we will see. So now see here, this is also combination of Coulomb force and both. So here the question is like this. The two equal charged identical metal spheres, identical and similar charges, equal and similar charges. How I came to know similar charges means in the question they are repelling each other given. In the question they have given repelling each other with a force. So therefore I have taken plus Q1 plus Q, 2 into 10 power minus 5 is equal to K into Q square by R square equation 1. So now force, now what happened? Another identical uncharged sphere C is touched to B. So now B and C are touched. So this is B and C. So B is having charge already, Q is having. Then C is having 0 charge, uncharged. Now these two are touching and separate means and placing in the midpoint means R by 2 distance. That means the charge on B and charge on C will be varied like that, Q by 2 and Q by 2. Already yesterday we have completed. So in conservation of charge and equal potential, identical means Q1 dash and Q2 dash are equal. That is, you will get here the Q dash is equal to Q by 2, means the charge on sphere B and sphere C is Q by 2, Q by 2. Sphere A is Q only. So now the force between A and C is repulsive and all are having the same charges or similar charges, not same charges, similar charges. Means positive. Therefore, FAC in this direction, repulsive force. Therefore, FAC is equal to, you will get, so K Q square by 2, that equal to 2 times of F will. So similarly, now FBC will, this is not same again because charges are different. FBC is equal to, this is in positive x direction, so consider as I cap. The vector is I cap. So now FBC is equal to K into Q square by, so here again Q into Q. So here this is FAC. FBC means Q by 2 into Q by 2, that is equal to Q square by 4 into R by 2 whole square, R square by 4. So 4 get cancelled. FBC is equal to, again, what is the answer? Force. Force minus I cap. So now the resultant force on C by these two. So this is the force on C by A, this is the force on C by B, but resultant force on C by A and B is equal to 2F minus F, that is equal to F newtons. That is equal to 2 into 10 to the power of minus 5 newtons. F is already given, 2 into 10 to the power of minus 5 newtons. So F is positive value, that will be along the line joining A and B. So in the direction. So the force acting, resultant force acting in the direction. I hope this is easy to understand. So next question you will see. So here see the point charges are placed vertices of a square side A, square of side A. Here the figure is shown like this. So how should Q and Q are related so that net force on each Q is 0. So net force on Q you have to find out. And to make it 0, what is the Q and Q relation? Charges are how much? So that is the first question you have to find out. See. So according to given question, net force on Q, here I will take. Here you can take, or on the opposite corner another Q is there, there also you can take. Each Q is asking 0. So here all are similar charges. So there is not mentioned any negative, positive. Negative means direction alone will change. So no problem here. So this is force 1 I will take. Force 1. And here this is the force 2. Means this is 2, this is 1. So this is 3 I will take. So now force 1, 2. The angle between these force 1, 2 is 90. Therefore, resultant force is like this. This is the resultant force. So by these two forces. So net force is 0. That means there is another force should act on Q by in the direction. So this is the force by this Q. The force by this. So this Q nature is what? So attraction means negative will come. Attraction means this is the resultant of these two forces. If it is a similar charge respect to Q, then this force also by the charge, third charge also force 3 will come in this direction again. So it will not be in equilibrium, right? It is not 0 then. There will be some resultant F3 plus F4, not 0. To make 0, the force should act, the force between Q and Q should act in the direction. So by that I can clearly say this is negative charge. The Q will be negative, has to come. We'll check now. Therefore, first of all, F1 is equal to F2 because same distance. F1 is equal to F2 and same charges also. That is equal to how much? Ki into QQ by A square, side A square. So this is equation 1. And now the resultant force by these two is equal to, we know resultant formula, root over F1 square plus F2 square plus 2F1 F2 cos theta. So these are equal forces. F1 is equal to F2. F1 equal to F2. The resultant force is equal to root 3F when theta is equal to 60. That equal to F when theta is equal to 120. Remember this. For instead of calculation, you can remember equal forces. And theta angle between them is 60, that is root 3F. Angle between them is 120, that is F. Angle that is equal to root 2 into F when angle is 90. So that is equal to F minus F, means 0 when theta is equal to 180. So that is equal to F plus F 2F, the theta is equal to 0. Means both are acting same direction, and equal means 2F. So this is the values. According to vectors, you know very clear this is. Again, means in gravitation, electrostatic and magnetic dipole, electric dipole, there this formula you have to use there. Wherever the vector angular momentum, wherever the problem related to vector addition, this is very, very important. So remember that. So now F1 and F2 are equal, and F1 and F2 force are equal, and angle between them is 90. So I will go with root 2F. Therefore, the resultant force is equal to, resultant force on Q is equal to root 2 into F, that equal to Q by K means 1 by 4 pi epsilon naught A square. So there is another equal force act opposite direction. This is acting in the direction. So opposite direction should act to be net force is 0. Net force is 0 means the force Fr, the net force Fr minus the force between these two, that is F3, is equal to 0. Net force, because this is Fr one direction, positive you take means F3 is negative direction. Here F3 is equal to force between positive Q, means Q and Q, that equal to, I don't know the nature of Q, but I will take that is Q only. So K into Q square, means here you have to take a net force means sum of addition of vector addition only. Minus you should not. Therefore F3 is equal to minus of F is equal to 0. F3 first of all find out, it will come automatically minus KQ square by, here distance is, it is the A and A. So this will be root 2A. The distance between, so these two charges is root 2A. So that equal to 2A square. So KQ by 2A square. So now these two are, the sum of these two is equal to 0. Therefore K into Q square by 2A square. Sum is equal to 0 means it will be minus root 2 KQ into Q by A square. So A square get cancelled. So KQ get cancelled means Q is there. Therefore Q is equal to minus Q. So that is Q is equal to, here Q is equal to Q into 2 root 2. Q into 2 root. Therefore Q is equal to, small q is equal to minus Q by 2 root 2. So then only the Q is equal to minus Q by 2 root 2. Then means on the each charge will be 0. So I hope this you understand. So similarly you can find out, because here I have no space. Similarly on each charge Q is telling on Q is 0. Then what is the nature of these Qs and how much Q value will be? So see on this Q, the force is like this and force is like this. That will be same, because same, this is only one equation only will get again KQ by A square. And here in the place of capital Q, small q will come. Therefore, here k into small q square by 2a square is equal to minus 2 root 2 q by a square. So here small q, k get cancelled. Therefore, capital Q charge is equal to minus q by 2 root. So here see q is equal to capital Q charge, how much should be? Q root 2 times of q and minus capital Q value. Our small q value is equal to minus q by 2 root. Here capital Q is equal to minus q by 2 root 2, or small q is equal to root 2 times of minus capital Q. So then only the net force on each charge is 0. Hope you understand here this case. So this should know the possible that entire system could be in electrostatic equilibrium means no, because here see these two forces charges are not similar, right? Not similar at the same way, they are not equal. Here these two charges are equal and these two charges are capital Q are equal, but all are not equal. So then no means net force is not 0. So net force should 0 on any of the particle means the charges will be equal. But here charges are not equal, so it is not in equilibrium. So this is also over. So next model we will see. So here 4 point charges are given fixed at the corners of the square A. Another point charge Q naught is placed at the height h vertically above the center of the square. So this model see simple I will explain. So here may you will understand means you have to take like this diagram. In the plane, the square is there like that, horizontal plane. So 4 corners there is a plus q, plus q, plus q and plus q. So from the center, so there is a one h distance, there is a q naught charge is there. Means by this, so there is a force is acting in the direction. By the charge also force acting in the direction. So the distance, to calculate the distance, this is a by root 2, because side A means the total diagonal is root 2a, then half of the diagonal is a by root 2, and this is h. So this distance you will get. So this distance you will get root over h square plus a by root 2 whole square. So now if you see this diagram clearly, this is the direction of force. And here there is a theta, angle theta is here, and it is 90 clearly. This is diagonal and perpendicular 90. So this is theta. Here theta I don't know. That's why here theta I will take. So now I will resolve the components. So this force into this one and this component. This is along x-axis, along y-axis. I will resolve the component. F is resolving along x and y components. Similarly, by this force also, by the charge also, the force acting like this, right? By the charge. By the charge also force acting like this. So now Fx will come, Fy will, right? So Fx component will be 0, only Fy components are added, right? Therefore, the 4 into 4 so here x and y components are Fx and Fy. Therefore, 4 Fys are there. 4 Fys are in vertical direction. So Fy is equal to, the Fy component is equal to F into cos theta. So then in this direction 4 are there, 4 Fy I have to find out. Means 4 into F into cos theta. F is equal to K into here Q square. Means Q into Q naught. Q into Q naught by the distance square. This is the distance between these two charges. So that is equal to h square plus a square by 2 into cos theta. Cos theta is equal to, so from this diagram, this is the theta. Therefore, cos theta is equal to adjacent side h by this one, h by hypotenuse, that equal to h by root over h square plus a square by 2. So this is equal to now 4 into q naught into h by 4 pi epsilon naught. This k value I am substituting. And here h square plus a square by 2, and here 1 by 2 is there, root over. So that equal to h square plus a square by 2 whole power 3 by 2. So here 4 get cancelled. Therefore, the force F is equal to, so Fi equal to F cos theta. So now the force, resultant force is equal to, means force on this Q naught experience using is equal to 4 into Fi. So that equal means Fi equal to F cos theta. The resultant force is asking 4 into Fi. 4 into Fi. So Fi equal to F cos theta, 4 into Fi substituted. Therefore, the required force, this is the required force, is equal to Q naught on Q naught. Required force, or the force on Q naught, is equal to Q naught by pi epsilon naught into h square plus a square by 2 whole power 3 by 2. So this is answer. So next one we will see. So wherever you take, no problem. Minus q. And at the centroid distance is, height will be divided into 2:1 ratio. That is the point centroid, you know, or bisecting line of angles. So this is centroid. There is a positive q is there at this point, centroid. So now this is distance. If it is the equilateral triangle side A, this distance is equal to a by root 3. Means h is equal to, you know, that root 3a by 2. It is dividing into 3 parts, 2 parts here to here and 1 parts here to here. So that equal to 2 get cancelled. Then a by root 3 is the distance. And this repulsive force, this is repulsive force in the direction. This is F1 by this charge. And here also positive. So that is also F1. And angle between these two will become 120 according to concept. So then that is equal, means F you calculate. And here also this is attractive force. And here the resultant. So the force will be in, the force will become here. Calculation of force will become. So we'll see how much this is. Not 0. 0 will not come because both forces. So the resultant of these two forces is also upwards. And this also in a upward direction. That is equal to, first of all, the resultant of this force you find out. F1 and F2 are equal, and angle between them is F1 and F2. This is the 2 and 3. F1 and F2 are equal, and angle between them is 120. This is because 60, here 60 means 30 will come. Here also 30. 60 gone means is 120. So 120. Therefore, F1 equal to F2, then is F only will come. That equal to F is equal to the calculation K into QQ by the distance a square into 3. So this is upward direction. Similarly, here also the this force by this is the negative charge. So attractive force also there. F3 also in the direction only there. Therefore, the total force on Q, is equal to F resultant plus attractive force. F attractive by third charge. So both are in the same direction. Then both will be added, and force is same, right? That is equal to 2 times of force K Q into F into 3 by a square. So this is 6 QQ. Here QQ will come, QQ by 4 pi epsilon naught into a square. So this is the answer. So this is not 0 because these two resultant are same direction, means angle between them is 0. If it is anyone is opposite direction, then force will be 0. But here both are in the same direction, the force is not 0. So this is another example, another model. So coming into last model of problem. So here three particles each of, means it is application of NLM you have to apply here. So see, the three particles each of 1 gram and carrying a charge Q are suspended from a common point. So here three particles are there, massless string, each 100 centimeter. The particles are in equilibrium and are located at a corners of equilateral triangle of side 3. Calculate the charge and Q of each particle. Means first draw the diagram because I already know, so I am very clear. So read, three particles are there here. And arranged at a corners of equilateral triangle. And these three are suspended from one point. This is the string of 100 centimeters. From one point, these are suspended from one point. So these three imagine. So along the string, there is a tension, you know, very clear. So on this, there is an electrostatic force will act. All are similar charges and they have given same charge. Therefore, Q and Q will take. Each charge is Q and 1 gram is mass is given. So now the force acting on them. So this is the force acting on this between these two charges, and similarly this is the force acting on these two. Here angle is 60 degrees. So angle is 60 degrees means the net force, electrostatic force on this charge is equal to, you will get √3 into F. √3 into F is equal to KQ square by A square. Distance between them is A square. This is the equation 1. Keep like this. Is asking to find out Q when it is in the equilibrium. So now here tension is acting in the direction. So resolve into components tension. So this is the centroid point. So tension. So now here is the, so here they are suspended from the point 3 rods with the theta is given. Means from the point they are suspended with 3 threads, which one is 100 centimeter length. So this is also 100 centimeter length only. Imagine. So now this is theta, means this is also theta will come here because these two lines are parallel lines will become. So here from division of tension, T cos theta and T sin theta. T cos theta is equal to mg will come and T sin theta is equal to the resultant of this force, that is equal to √3 F will come. T sin theta √3 into F. So that is equal to KQ square by A square. So now here tan theta is equal to subtract this, means divide these two equations. Tan theta is equal to this one by this one. So that is equal to √3 KQ square by mg into A square side square. And here if you take tan theta here from the diagram, try to get the tan theta. So here see tan theta we have to find out. So from the tan theta, see this is the length L they have given. So consider length L. Afterwards we can substitute. This is the length L. And this you know this is equal to A by √3. Side means A by √3. So this is the perpendicular point from this equilibrium point. This is the 90 degrees. Therefore tan theta is equal to, from there, so this is this one is, we know, opposite side by, so this is L and this is, we'll get opposite side means A by √3. Clear, this is A by √3. Adjacent side, this is root over L square, means L is hypotenuse and this length I don't know. This adjacent side I don't know. That's why root over L square minus A square by 3 I can substitute. So root over L square, 3L square minus A square root by 3. So these 3 get cancelled. That equal to tan theta is equal to, I will get tan theta is equal to this root 3 and 3 get cancelled, means here root 3 will come. This root 3a by answer is root over 3L square minus A square. This is the tan theta value. So now this tan theta value, if you substitute, tan theta value A by root 3 into L square minus A square by 3. So this is value, and here you have to compare the A value and L value. L value is equal to here 100 centimeter, and equilateral triangle side is 3 centimeter. 3 and 100 is very, means compared to side A is very less than L. Is very less than L. So if you substitute, means you will get some points, 0.0 value. That's why you will neglect this. So A square values will neglect. So A will take common and 3L square by means. So you will get answer tan theta is equal to A by, this is 3L square will come, root 3 means root 3L will come. That equal to A by root 3 into L is the answer. So tan theta, after substituting this condition, L means A is very less than L. So after that simplification, you will get tan theta is equal to A by root 3L. So now A by root 3L is equal, means A by root 3L is equal to root 3 into L is equal to root 3 into KQ square by mg into A square. So root 3 become 3 here, 3 into L. So that equal to this A cube. So mg A cube by 3KL is equal to Q square. Therefore Q is equal to root over mg into A side of the A cube, mg into A side of the triangle by 3K, K value 9 into 10 power of 9 into length of the string here. So this is the answer. So if you substitute given values, you will get answer will be like 10 power minus 8 coulombs. So 10 power answer should be 10 power minus 8 coulomb. Right. So this is answer. So now similarly here see, this also same like this, but it is easy model. Two identical small spheres are suspended from the same point. So same point. Two identical spheres are suspended from the same point by the thread of 1 meter. The length is equal to 1 meter. Each sphere is given a charge, means charge is 120 nanocoulomb. Charge is given, Q charge is given, consider. Afterwards you can substitute. So now they will repel each other. They repel each other to the distance. Because of why they will repel means because of charges there will be a electrostatic force is there. Electrostatic force. So on this particle in the direction, on this particle in the direction. So they will repel each other with some angle with a suspension point. This is the suspending from same point. So like this. So now angle theta is asking to find out angle theta and tension in the string also T. So general, and they are separated by the distance D, consider here, or R you can take. So afterwards values you can substitute here. Therefore, so similarly tension is divided into components, means resolve into components. So T cos theta, because this line and this line are parallel. So theta, here also theta same. So T cos theta is equal to mg of the sphere or small sphere, and t sin theta is equal to Fe, that equal to kq square by d square. So now again tan theta is equal to, so here tan theta second equation by first equation d square into mg, or simply q square is equal to mg tan theta. Mg tan theta is tangential force, mg tan theta into d square by q square. Sorry, k is equal to, or q square is equal to by k. Q is equal root over mg tan theta k by, substitute na, q value is given, d values are given, k value you know already, m value is given, l value is also given. Tan theta here you will get tan theta same again. So this is d by 2 will come, and this is 1 meter. Therefore tan theta is equal to adjacent 1 by 1 d by 2. So that is equal to 20. That value substitute na, you will get answer. So these are the models and applications on Coulombs law of force. So like this, similarly, different models and different problems are there. Everywhere you will apply magnitude of force and direction of force you will consider, and depends on the given question, comparing the values and equating the forces, we will find the final. And two more model of the problems are there. One is null point and superimposition of finding the superimposition. So null point calculation already you know. In electric field, I will explain that point. That's why here I am not taking. So if anybody required, send me some WhatsApp or in the comments which model of problem you want. Then I can conclude that. I can explain in